Okay, so let's see. Let's work through these, right? Numbers 1 to 5. So the first one, assume x and y are differentiable functions of t. All right, find dx dt. Okay, so we're going to differentiate this function. So we've got. Oh, why is it off? Turn it on.
Are you recording?
Yes. We are recording, yes. Okay, so we're going to have 8, oh, she can't, 8x dx dt plus 9y squared dy dt equals 0. And we're going to substitute in everything we can substitute in. So we've got 8 times negative 1, and we're looking for dx dt, plus 9. I don't have y, so how do I figure out y? Yeah.
You plug in the x.
Yeah, go back up to the original equation. So we've got 4 times negative 1 squared plus 3y cubed equals 28. So that gives me 4 plus 3y cubed equals 28. Subtracting 28, subtracting 4, we get 24, divide by 3. So the cube root, and we get y equals 2. So now I can go back over here and I can put the 2 in for y. And then dy dt is 8. It is really loud.
Is that whose class?
That should matter.
It's very loud.
It's motivational. It doesn't have to be that one.
Okay, so we have negative 8 dx dt. I'm sure I'm loud too sometimes. When we do the quadratic formula, I do that loud. Okay, negative 8 dx dt. This is going to be 36 times 8. Who's got that for me? Equals, what's 36 times 8?
288.
288? Thank you. Okay, so just a matter of solving for dx dt. That's going to be negative 288 divided by negative 8, which is 36. There you go. Okay. So that was pretty straightforward, right? All right, water is falling on a surface, wetting a circular area that is expanding at a rate of 10 square millimeters per second. How fast is the radius of the wetted area expanding when the radius is 116? Okay, so first we have to come up with a formula. And we're talking about a circular area. And let's see, and we're talking about area. So area equals pi r squared. Okay, so if I differentiate that, dA dt equals 2 pi r dr dt. Okay, so let's see what we have here. Water is falling, is wetting a circular area that is expanding. So dA dt is 10. Okay. How fast is the radius expanding? So we're looking for dr dt when r equals 116. So we have 10 equals 2 pi times 116 dr dt. So that means we've got 10 divided by 2 pi times 116 equals dr dt, which equals, let's see, so dr dt equals 5 over 116 pi, which is approximately 0.0137. Let's see, this is radius, so it's millimeters per second. Oops, millimeter per second. Okay, and you can leave it as 5/116 pi. You don't have to do the decimal. Okay, we good on that one? Okay, how about a fist of 5? Okay.
Like, can you give us a list of like the formulas we have to like have memorized for like the test?
You should know the area and volume formulas for, yeah, let me go back and I'll do that after we finish this, okay? Okay, a spherical balloon is being inflated. The radius of the balloon is increasing. Okay, so I've got dr dt. The radius is increasing at a rate of 1/pi inches per second. Find the rate at which the volume is increasing. So I'm looking for dv dt when the radius is 1 inch. All right. So obviously we're looking for the volume of a sphere. Volume equals 4/3 pi r cubed. Okay. So that means dv dt equals, we're going to bring the 3 in front, so that becomes 4 pi r squared dr dt. Okay, looking for dv dt, so we have dv dt equals 4 pi r squared, so that's 1 squared, times 1/pi. So we get, let's see, 4, the pi's are going to cancel, so it looks like it's just 4. Okay, let's look at the unit here, right? So this, let me go back down here, right? So here the radius was in inches. So this is inches squared times dr dt, which was inches over seconds. So my dv dt is going to be inches cubed over seconds. Okay, so I go back to the formula and I substitute in the units there. Yeah.
Can you do that again with the units?
Mm-hmm.
I just wasn't.
Okay. So going back to the formula before I substitute any numbers in there, right? So I'm looking at dv dt, that's my unknown, right? 4 pi, that doesn't have a unit, but the radius has a unit, and the radius squared, right? So that'll be inches squared, right? My radius is in inches. And then dr dt, that has a unit, and that was given as inches over seconds. So now I've substituted the units back into the original formula. This ends up being inches squared times inches, which is inches cubed over seconds. Yep.
Because can we just make the assumption that it has to be cubed because we're talking about volume?
Yes.
Okay.
But every once in a while, I've seen questions on your exam that say to verify the units or something to that effect. Okay. Okay, number 4, all edges of a cube are expanding at a rate of 3 centimeters per second. How fast is the volume changing when each edge is 10 centimeters? Okay. Okay, what's the volume of our cube? If this is, I'm going to call this X. If that side is X, what's the volume? X cubed, right? X cubed, okay? So let's see. When I differentiate this, I get dv dt equals 3x dx dt, all right? Sometimes I'll differentiate it first and then figure out what all my values are. Sometimes I'll write my given values first and then differentiate. It doesn't matter. Okay.
Yeah.
Thank you. Yeah. Thank you. Yeah.
On the test, if we use a different letter to represent, will it matter?
No, the only reason I use it, it actually makes more sense to use S. I don't like to use S because it looks like a 5. That's why I did X. But it makes more sense to say S. Okay. Okay. So all edges of the cube are expanding at a rate of 3 centimeters per second. So what's that give us? That's the dx dt. Okay, how fast is the volume? So we're trying to find dv dt when x equals 10 centimeters. So dv dt equals 3x squared, so that's 10 squared, times dx dt, which is 3. So we get 900. Okay, now let's look at the unit. So we have, let's see, x is in centimeters, so that's centimeters squared. Dx dt is in centimeters per second. So sure enough, that gives us centimeters cubed per second. And again, you can assume that it's centimeters cubed because it's volume over time. Okay? Okay, before I do number 5, I know I had a few of you give me some 3s when I asked you for your feelings or your fist to 5. Does that mean you have questions maybe? Things you're not understanding? Or you're just not feeling totally confident?
Really confident.
That I understand.
It's hard to find out what to do.
Mm-hmm.
Which is it, dx or dv or whatever? That kind of gets jumbled in my brain. D stuff.
Okay.
When it comes to volume, every time it's a cube, that's when you do like x to the third. And then when it's the other volume, you do 4 over 3. Is that?
Okay, before I do number 5, let me go back and see if I can.
Wait, depends on like what you're measuring. Whether it's a cube, then it's x cubed.
Okay.
Like, if it's like a cylinder, then it's
Let me. Yep.
Do you still have the test manual?
I think we'll push it to Wednesday.
Thank you.
Okay, so let's see.
But can we actually like review for the test?
We are reviewing. That's what we're doing. Yeah. Okay, so let's do some area, right? Area of a circle. Actually, let me see if I can grab. I don't forget any. Oh my goodness. No, you cannot. Okay, looking for your formulas here. Sections. No. Okay, let's see here. Area of a circle. Do you remember the area of a circle?
2 pi r. No,
pi r squared.
Thank you.
Come on, Caitlin.
You're better than that.
Are we not doing 5? We're writing units.
Okay. 2 pi r is the circumference. Sometimes you'll see the circumference just written as pi times the diameter. Okay. If we talk about a sphere, then that's referring to volume. What's the volume of a sphere? 4/3 pi r cubed. Okay, I think that covers the circles. Cylinders. Okay, again, a cylinder is basically 3D. If it's three-dimensional, you're talking about volume, right? A cylinder is three-dimensional, right? A cylinder is easy to remember the formula, right? You've got a circle on the top, but then when I think of volume, I always just try to think it's area plus the third dimension of height. It's typically what it is. So you've got a circle on top, so it's pi r squared, but then you've got the height of the cylinder. So pi r squared h. That's the volume of your cylinder. Okay. Let's see, a cone. Cone. Okay, usually we're referring to what we call a right circular cone. Remember that phrase from geometry? Okay, never mind.
Nope.
Right circular cone, which means,
Oh, that was first.
yes. Okay, there's your right circular cone. I taught geometry, that's what it is. Okay, so the volume of a right circular cone is 1/3 pi r squared h. Okay, now the way I remember that, it looks very similar to your volume of a cylinder, except only 1/3. So I just kind of imagine, well, okay, it's going to take, if I put these cones together, it's going to take 3 of them to make a cylinder. Okay, so if you could put another cone like this, right, and then another cone like this.
Oh, like that.
Okay, then it's going to take 3 of them to get that cylinder. That's how I remember it. Okay. Triangles. You have area of triangles. So your area of a right triangle. These are all formulas that you are expected to know. These are geometry formulas. Okay. Area equals 1/2 base times height.
Thank you.
Let's see here. The area of an equilateral triangle.
So do we have to know these just for the exam, or like we need it at least like for your test?
You have to know these. You should know these. These are geometry formulas. I know you had a bad geometry year, but that's the fact is these are geometry formulas. Who remembers what an equilateral triangle is?
Each sides are the same.
Yes, all 3 sides are the same length.
So is it like 3s?
So let's see here. Right, S, S, S. This is H. Right, the area is square root of 3 over 4 S squared. I usually forget the equilateral formula also. We can find the height of the equilateral triangle by taking the square root of 3 over 2 S.
What's that?
That's the height of the equilateral triangle. Let's see here. I think that's all the formulas that I would expect you to know. And the equilateral one, I'd probably give it to you, and I'm pretty sure they would give that to you also.
You just need to have.
Volume of a cube is.
Oh, cube. So area of a square is side times side, or S squared, right? Area of a cube is, volume of a cube. S cubed. Okay. Area of a rectangle is length times width.
These ones we should know.
You should know. Volume of a rectangle, length times width times height. Okay. I mean, I'm going to just be totally blunt with you. The only formulas that you should not know or may not know would be the cone and the equilateral triangle. You should know the other formulas.
I didn't know.
Yes.
Yes. Now we know.
Absolutely
Now
should
I
know
know.
those.
So it's fine.
Okay.
I think cylinder and sphere.
I was good till now. Now I know. Good. I'm good now. Good.
Okay. All right. I'll give you that it might have been so long ago that you forget. Okay.
What's the area of a cube?
A cube is not going to have an area. A cube is a three-dimensional figure. It's only going to have a volume.
Okay.
A cube is a square with a third dimension.
Silly.
Okay.
Silly to that. I knew that one.
Well, a piece of paper has a third dimension because it does have a depth. Yeah.
It is a rectangle on a
Maybe.
Okay. Number 5. This is the one you all said you had trouble with. An aircraft is climbing at a 30-degree angle to the horizontal. Okay, so here's the horizontal. The aircraft is climbing at a 30-degree angle to the horizontal. So if it's climbing, all right, let's see. Okay. How fast is the aircraft gaining altitude? Right, so gaining altitude, let's call this A, right? That's my altitude. So I'm looking for dA dt. If its speed is 500 miles per hour. Okay, so what did I just do? I just lost it in my notes. Okay, its speed is 500 miles per hour. So we're looking for this, right? I'm just going to write speed equals 500 miles per hour. Okay? Okay, so let's see. Let's label these. We're going to call this is X. I guess it doesn't, we can call that A or Y. It doesn't matter. Aircraft is climbing. I'm going to just call this, I'll call it Z. Okay? Again, it doesn't matter. So, what do we know?
It's pod.
It's a 30, 60, 90. Mm-hmm. Z is equal to 500. Okay. It's traveling at 500 miles per hour. So that's how fast it's traveling in that direction. right? We're trying to find how fast it's increasing its altitude.
So then you would do the trigonometry. You would sine would be
Sine
opposite.
of 30 equals the opposite over the hypotenuse, right?
And then you do 500 sine 30 is A. But then how does derivatives come into play?
Yeah, I'm going to leave this as A over Z for now. Okay, because I'm writing so this is where we have to be a little bit careful. We don't want to substitute the values in early. Like if you look up here, right, we didn't substitute the values in here. We substituted it after we did our derivative, right? We didn't substitute them in here, right? So we have to be careful that we don't substitute the values in too early, right? So this means I'm going to rewrite this as Z sine 30 equals A, because dA dt is what I'm trying to find. Everybody good with that?
Yeah.
Okay, so let's differentiate. So this is the first times the derivative of the second. Now, what is sine 30? What is the sine of 30? Yes.
I just have a question.
It's 1/2.
So, say you didn't put the Z in front before, and you just did the quotient rule, would that make it a lot more difficult?
No, it's just different. I just prefer product rule over quotient rule. Yep. In fact, now that I'm looking at it, I should not have even put the 30 in there. Sine of theta. Sine of theta. That's my formula, sine of theta. Okay?
Why don't you keep the 30?
Because again, we don't want to, in this case it will work out okay, but we don't want to have that policy or habit of substituting in the values early. You want to come up with your equation first, differentiate, and then substitute in. Okay, so this is going to be the first, so Z times the derivative of sine theta. What's the derivative of sine theta? Cosine theta d theta dt. We'll talk about that in a minute. Plus the second times the derivative of the first. What's the derivative of z? 1 dz dt. And that equals dA dt. Okay? All right. So we know z. Z is 500. Do we know the cosine of theta? Cosine of 30 degrees.
Yeah. It's radical 3 over 2.
Radical 3 over 2. What's d theta dt? At what rate is the angle changing?
30 degrees.
No. The angle is 30 degrees. Theta is 30 degrees. Is the angle ever changing? Does it indicate that the angle changes? There's no rate of change in angle, so this is 0. D theta dt is 0. It's not changing, it's a constant 30 degrees. Okay? Plus sine of 30 degrees times dz dt. What's dz dt?
Wouldn't it be 0 because if you're saying Z is 500?
How fast is the aircraft changing altitude if its speed is 500 miles per hour? That is dz dt.
So is Z
That is dz dt. That's the rate of change, right? So this is dz dt. Right? So z is not 500. We don't know z, but it doesn't matter. We don't know z, but it doesn't matter because z times 0 is 0. Okay, so this is 500. Okay, let's just look at that again. Here's our formula. We differentiate it, right? D theta dt is 0. So although I don't know z, it becomes a non-issue because it's going to zero out. This is the speed. Speed is the derivative of the distance, right? So speed is dz dt, so that's 500. Okay, that makes sense. Now, what is the sine of 30?
Oh, I know 1/2.
1/2.
So then it's 250.
Yes. Now, in this particular problem, we could have substituted in earlier and gotten the same answer. Okay? And I hate those type of examples because you guys see that and you're like, oh, I'm not doing all that work. And then all of a sudden we have a problem that requires all that work and you don't know how to do it. Right? Yes.
So, do you just not give a unit because it doesn't give us?
No, it is a unit. So let's see. So
Oh, would be miles.
my unit is coming from this, right? So sine theta dz dt, right? So sine theta, that's just going to be a 1/2, so that's not a unit. Dz dt is in miles per hour, right? And this equals dA dt. So this is going to be miles per hour. The rate of, right, the aircraft is gaining altitude at a rate of 250 miles per hour. Yes.
So I actually got the right answer, but
Mhm.
I did it with pi/6 instead of doing like 1/2. So like I did so I had my triangle as like A as your base, and then B, and then C as your hypotenuse. So then I did dV over dt equals sine pi/6 times dV over dt.
Pi/6 is 30 degrees.
Yeah, but then when I did that, I did like oh yeah, I guess that did.
Did you substitute in the 1/2 for the sine of pi/6 early?
No.
Like if you substituted in like right here?
Let me get back to that.
Okay. Yes.
I just kind of missed this part. Why is d theta over dt equal 0?
Because the angle is not changing. The angle is remaining constant. It's a constant 30-degree angle. So if it's a constant, when we take the derivative of a constant, that's 0.
Okay. So it's like okay.
Okay. Okay. All right, let's look at number 6 together. A man 6 feet tall walks at a rate of 5 feet per second away from a lamppost that is 22 feet high. At what rate is the length of his shadow changing when he is 60 feet from the lamppost? Okay, so let's see. Here's my lamppost, right? A man 6 feet tall walks at a rate of 5 feet per second away from the lamppost. So we've got a man that's walking away from the lamppost like that. The lamppost is 22 feet high, right? Right, so we're going to put the man right here. Here's the man. He's 6 feet tall, right? At what rate is the length of the shadow changing? So we're talking about this length right here. When he is 60 feet away from the lamp post, right? So I basically have two triangles here. I'm going to call this X. So I've got a triangle that looks like this, where we've got an a y, a 6, and then I've got a triangle that looks like this, where I've got an x plus y and a 22. Okay. Again, this is geometry. I have similar triangles here. Okay. Similar triangles here. So I can set up a ratio. Okay. So I've got the ratio of these two sides, right? 22 to 6 equals, okay, let's look at the ratio of, yeah, exactly, x plus y to y. Okay. Okay, I'm going to pause and I'm going to let you continue on that one now. X60? 60?
I put it as 6.
Because
I put y as 6.
60 feet away.
Oh, I see what you're saying.
Well, it's not x plus y because the y is the shadow. Yeah, but
Well, yeah, let me just show you. Okay, let's go ahead. This is going to be 22y equals 6x plus 6y, right? Cross multiply?
Yeah.
Okay. So subtracting 6y, we get 16y equals 6x. What am I trying to find? At what rate is the length of the shadow? So what am I trying to find? dy dt. Okay. So I'm going to isolate the y. So y equals 6 over 16x. So y equals 3 over 8x. Okay. I don't think I need the 60. So if I differentiate, I get dy dt equals, the derivative of 3/8 x is 3/8 dx dt. So I can do this without using the 60. Because we know dx dt is 5. Yes. So dy dt equals 3/8 times 5, which is 15 over 8.
there was just some
Who was at the door?
brain and you're rolling.
Oh. 15 over 8, and then what's the unit? What was dx dt? Feet. Dx dt is feet per second, so this is just feet per second. So I didn't need the 60. Okay.
Why is it there if we didn't use it?
What shadow? That was.
No, the man shadow.
But he's behind me.
So his shadow, as he's walking away from the lamppost, right? As he's walking away from the lamppost, his shadow is increasing at a rate of 15 over 8 feet per second. Okay. Hi. She's not up here. She's probably down in the commons.
Oh, Nikki's not here at all.
Oh, she's not here at all. Never mind. Okay. Okay, number 7. All right. The height of a cylinder. What do we know about cylinders?
That it's one.
The volume is
It's V
pi r squared h. Pi r squared h.
Yeah.
Okay. Here's my cylinder. Okay. the height of the cylinder with a radius of 4. Now, one thing we know about the radius of a cylinder is that it doesn't change, as opposed to the radius of a cone, right? That radius is going to change depending on where we are on the cone. With a cylinder, the radius does not change. Okay, so the height of the cylinder with a radius of 4 is increasing at a rate of 2 centimeters per minute. Okay, so radius equals 4. The height, dH dt, is increasing at 2 centimeters per minute.
No, it says the radius.
No, the height of a cylinder with a radius of 4, right? That's why I made the point of saying radius does not change on a cylinder. The radius remains constant on a cylinder. Find the rate of change of the volume. So what are we trying to find? dV dt with respect to time when the height is, when h equals 10 centimeters. Okay. So what are we going to do? Right. So we've got dV dt equals, this is a product rule. So first, pi r squared times the derivative of the second, dH dt, plus the second, so we've got pi h, times the derivative of the first, 2r dr dt. Okay.
Oh, so you just keep the variable with whatever the first it is?
Well, the pi, it can be with the 2. It doesn't matter because we move it later. The pi could be over here if you want it to. It doesn't matter. Okay, do we have everything? We're looking for dV dt. Do I have r? Yes. I have dH dt? Yes. Do I have h? Yes. R, dr dt. Okay. So dV dt equals pi times 16 times 2 plus pi times 10 times 2 times 4 times, what's dr dt? 0. So this whole thing is 0. Right.
Oh, because it's constant.
Yes. It's a constant. So dV dt equals 32 pi. All right, what's our unit?
Centimeters cubed over minutes.
Okay, yeah. Because remember, so we're looking at this right here, right? Pi r squared dH dt. Well, that's pi. R is in centimeters, so this is centimeters squared. And then dH dt is centimeters per minute. So that means I'm looking at centimeters cubed per minute. Okay.
Miss Mary, I'm gonna go to get us some water real fast.
In 15 minutes.
This way.
Yep.
I had a question. So, when you did the product rule, how did you? I don't see how you screwed that up.
Okay, let me because I confused you with this part right here.
Yeah, it was. I always do like times d.
Okay. So we've got first times the derivative of the second. So I'm calling this my first. Okay. So plus the second times the derivative of the first. Okay, so taking the derivative of pi r squared is 2 pi r dr dt.
When you did the first part of it, like the first times the derivative and the second, derivative of h is just dh over dt.
Right.
That's it. Okay. That's where I get lost. Do you have to put
Well, the derivative of h, so that's 1 dh dt. Yeah, we have to put the dh dt there. Okay, let's look at number 10. Actually, I want you to look at number 10. See if you can do this. Okay, so dh dt is 8 feet per second, right? So obviously I have a triangle here. Find the rate of change of the angle of elevation. So I'm looking for d theta dt when the balloon is 25 feet above the ground. So when h equals 25.
We can use different variables. Like
Of course. Yep. Okay. So let me see here. I have an opposite and an adjacent. So I'm going to say that tangent theta equals h over, I'll call it x, right? This is x. Okay. So again, I like the product rule better than the quotient rule. So x tangent theta equals h. Okay, and then let's see if we can differentiate that. So the first times the derivative of the second, which is good, secant squared theta d theta dt equals dh dt. Oops, I'm sorry, I forgot to do the other part of it. First times the derivative of the second plus the second,
dx dt.
okay, plus the second times the derivative of the first, dx dt, equals dh dt. Okay, now let's substitute in what we have. So I have x is 60. Is that right? And I've got secant squared theta d theta dt plus tangent theta. I don't know theta yet. Dx dt, what's dx dt?
0.
0, good. Equals dh dt, which is,
How do you know dx dt is 0?
because the man does not move. Okay. So how am I going to, so I've got 60 secant squared theta d theta dt. Well, d theta dt is okay because that's what I'm trying to find. But how do I figure out theta?
Oh, you can do it now, right? Can't you just plug it in now with the tangent of? Can you go back and then plug tangent theta equals like the 60, the y, the 25 over 60?
Yes.
And then that's where you.
So, yeah, now what you could do, okay, all right, so we know that if h is 25, now I have two sides of my triangle, right? I could figure out tangent theta and then figure out theta. Or the way I did it actually, I have a triangle here that is 25, 60. I figured out that this other side has to be 65. Everybody follow me? Okay, they gave us the 25, so now using Pythagorean theorem, I figured out that that side is 65. Now I can figure out secant theta. So secant is the reciprocal of which one? Cosine, right? So secant theta, right? Cosine is adjacent over hypotenuse, so secant theta has to be hypotenuse over adjacent. Okay, 5 goes into 30. 5 goes into 60 how many times? 5 goes into 36 times, so 12 times, right? So this is 13 over 12. Everybody see how I found that? Okay, so now we can go back and we can do 60 times 13 over 12 squared d theta dt equals 8. So let's see, that's 60 times 169 over 144. Okay, so we're going to use our calculator, right? And we're going to do d theta dt equals 8 divided by 60 times 169 over 144, which comes out to, according to my notes, about 6.5 degrees per second. Okay.
Yeah.
So the process, right? We write down everything we've been given. We come up with our formula. We differentiate, and then we look to see what information I still need. So we differentiate it, and when I differentiate, I was like, okay, wait a minute. I don't know secant theta. I don't know theta. So then I went back to my triangle and figured out a way to find out what secant theta is. Yes, Laura.
What happened to our tangent data though? Like,
When
I know
we
that just
because dx dt was 0. The person he doesn't move. He stays 60 feet away the whole time. So if it's a constant, when I take the derivative, it's going to be 0. Yeah.
Would it have worked if you found theta like by plugging into the tangent?
Yes. Yes. Mm-hmm. Yeah.
I did it like the quotient rule way, and I did not get that.
Okay.
I don't know what happened though. What did you write? Well, okay, I don't know how to change it into degrees, like on my calculator. You might be in the room. Oh, I just don't know how to do it soon. But I got 288 over 2,490. But I don't know.
Why is it?
I'd have to look at it, I guess.
it's not the times.
Gabby, you had a question?
Yeah, whenever I was put like the 8 over 60, that whole thing in the calculator, it's getting a different number than 6.5. It gets like 0.113.
Oh, use this calculator. Okay. 60 times 169 over 144, right? Okay, so I did.
Trying to listen to this word.
This is 8 divided by 60 times 169. Oh, I need another parenthesis there. $60 times 169 parentheses divided by 144 parentheses. Is that correct?
Mm-hmm.
Okay. Okay. Oops. Did I do something wrong? did I do? Okay, let me do it this way then, right? Let's see. 169 divided by 144.
You put an extra 4.
Oh,
That's why she got it.
okay. And then we're going to multiply that by 60. Right? And we're going to multiply
And do 8 divided by that.
8 divided by that. Well, that's not going to come out to.
Well, maybe you can do the same thing.
Okay. Let me just go back here and look in my notes here. Let's see. My notes I did 8 divided by 60, right? And then
Well, because you're dividing by a
times
fraction, you flip it.
144 divided by 160. Oh,
Oh, because you're dividing it by a fraction.
That's
Look at that, even I tried flipping it and multiplying it. It still didn't matter. You math and math.
okay. Hold on a second. I think I figured out something. Okay. Okay. So this answer that we're getting on our calculator, I didn't write my notes clearly, and I'm sorry. The answer that we get when we do this math right here is in radians,
yeah.
Oh.
right? This is radians per second.
Oh, that's cool.
So then I changed it to degrees per second. So if we take that, how do we change radians to degrees?
You go in the mode.
Or 180 over pi.
Times it by 180 over pi.
Can we have our answer in radians instead of the
Find the rate of change of the angle of elevation. Yes, you can.
Now, how do you know that that's in radians?
So then would you have to do like 0.13 pi or and then like
That's a good question, Ben, and I need to find the answer to that. I don't know. Okay.
Miss Murray.
Is it because it's